Let's talk all about enzymes and our biochemical reactions that they create. So far, we've talked a lot about how things normally happen. But here in the biological world, we have this fascinating protein, enzymes. There's lots of different types of enzymes. And metabolic reactions are controlled by enzymes. Enzymes, they are the most important protein, and they basically speed up any biological reaction. They lower the activation energy, which is the energy required to kind of kickstart the reaction. So if you have an enzyme, then you need less energy to get it going. Because they speed up the reaction by lowering the required energy, they're called a catalyst. And a catalyst is any substance that speeds up the reaction without permanently altering or changing the reaction. Catalysts don't change the pathway of a reaction, and they also don't change the output or the products of it. They just carry along, work as a helping hand, if you will. Kind of like, come along, speeding up the process. Enzymes are very specialized molecules, and they bind to those reactants or that substrate. And they help to break and form bonds, of course, by releasing these newly created products. Enzymes are not changed in the reaction, and they can be used over and over and over again. They're critical for regulating life's processes in all organisms. Here we have an example of a lock and key method. Here's my enzyme. It's just kind of sitting here. Remember, it's a protein sitting there. And along comes my substrate. Well, the substrate binds to the enzyme, and we call this an enzyme substrate complex. Got real creative there. Okay, so this enzyme substrate process is now in the enzyme, right? It's carrying it, and it's helping it along. The substrate helping it along, and it's changing. You see, we go from this purple molecule to now this orange and green one, where it's changed or carried along this reaction. This enzyme product complex is formed once the reaction is over. So once the reaction is over, we have this enzyme product complex. And then, of course, the enzyme releases the products. And it can be used over again. It's now available for more substrate. This enzyme function, or lock and key model that we use for enzymes, is just a generalized diagram to have biology students understand, what's happening here. We have this protein, and there's some sort of substrate, which can be a number of many things. The enzyme binds to the substrate. It creates this enzyme substrate complex. In that complex, the enzyme helps along the reaction, speeds up the substrate's reaction, and then it releases the products. And it just hangs out as an enzyme again, waiting for another substrate. We could go through examples of enzymes, but what you have to know is that they are very specific to what it is that they're doing. They have an active site that only fits one type of substrate, or the reactant. Remember, the reactants are the things, they're A plus B, if you will, and we're going to form a product here. So each of these reactants has a specific enzyme that only reacts with that particular thing. So once a substrate connects and binds tightly, it's an induced fit. It is real specific to any old enzyme. There's an active site on the enzyme, and by active I mean that's the location on the enzyme protein where the substrate just kind of binds to it. And it's important to know that that is specific to the enzyme and to the reactants. This can also work in reverse. Enzymes can break bonds in a substrate, and they can form bonds in a substrate. So they can do both. So here we have our substrate again, and it is going to bind to this active site. Remember, once it's bound to it, we have an enzyme substrate complex. Then some reaction forms, right? The reactants are formed products, so they are changed, and then the enzyme releases the products. But how this diagram is different is that here we have one substrate, and at the end we have two products. So this enzyme sped up the process of breaking apart that reactant. This would be like I had my product, which is now my reactant, and I needed an enzyme to take it apart. Enzymes can also make bonds between substrates in order to form a single product. So they can encourage bonding. Substrates can bond to the active site, creating this complex. And then these two items right here, these two reactants, they remain unchanged, but they just bond together. And then once they're bound together, the enzyme releases them. So this product is new, but these guys right here, the substrate is unchanged. It's just formed a new bond. How we stop enzymes from working, or really any protein for that matter, is we denature it. It goes through a denaturation process. Enzyme's active site, it can kind of get deformed or lose its specific shape. And when that happens, there's a complete loss of biological activity. It no longer carries on its function. This happens sometimes to the protein when there's been some sort of environmental change, maybe an extreme change in pH or temperature, or some ions have changed. Perhaps the solubility or the concentration, something has changed. But some enzymes can be renatured, to their original shape, but that doesn't always happen. So a normal enzyme, like this, can be put together. That's when you crack open an egg, the white part of the egg, that is a natural protein. But when you apply a high amount of temperature to it, you heat the egg in a frying pan, you basically denature the actual protein and it turns white. So it has broken apart. It no longer functions the same. Most of the time it doesn't look the same.